Today, we're talking about one of the absolute wildest rules in all of physics, quantum tunneling. You can think of it as the universe's very own cheat code. And believe me, it has some pretty mind-bending consequences.
So let me just start by asking you a question. Could you, right now, just decide to get up and walk straight through a solid wall? Sounds like something straight out of a comic book, right?
Well, in our everyday world, what physicists call the classical world, the answer is a big fat no. But down in the bizarre, tiny world of quantum mechanics, the rule isn't never. It's more like almost never. And that tiny, tiny little slice of possibility, that's where our story really begins.
To really wrap our heads around this, we need to understand this sort of quantum ghost rule. It's what allows tiny particles to show up in places they just have no business being.
All right, let's get into the nitty-gritty. How does this seemingly impossible magic trick actually work?
So the official definition of quantum tunneling says it's when a particle gets through an energy barrier even though it doesn't have enough energy to do it. Okay, what does that actually mean? Think of it like a ghost just casually slipping through a solid brick wall.
And this is where the difference really clicks. In our world, if you roll a ball up a hill but don't give it enough of a push, what happens? It rolls right back down every time. But in the quantum realm, it's a whole different ballgame. A tiny particle in that same situation has a chance, a small one but not zero, of just appearing on the other side. It doesn't go over the hill, it tunnels right through it.
So how in the world does it do that?
Well, the secret sauce here is that quantum particles are weird. They're not just tiny little dots, they also act like waves. And because they're waves, their presence can kind of spread out and leak into areas that should be off limits, what physicists call forbidden regions. And that gives them that chance to just pop out on the other side. And this right here, this is the math behind the magic. It's the famous Schrödinger equation. Now don't worry, you don't need to solve it. Just know that this formula is what describes that strange wave-like behavior. It's the tool scientists use to calculate the exact odds of a particle actually making that impossible jump.
Okay, so particles can teleport through walls. Kind of cool, kind of weird, but why should you care? Well, it turns out this ghost rule is creating a massive headache inside every single piece of technology we use today.
I'm not kidding. That exact same quantum cheat code is right now wreaking havoc on the smartphone in your pocket, the laptop on your desk, you name it.
Here's why. Inside a computer chip, you have billions of tiny on-off switches called transistors. To work properly, they need tiny little insulating walls to control where the electrons go. But here's the catch. As we've chased Moore's law, making everything smaller and faster, those walls have gotten ridiculously thin. We're talking just a few atoms thick.
And you know what happens when a wall gets that thin in the quantum world, right? Yep, the electrons just tunnel right through it. They leak out all the time, even when the switch is supposed to be off. As you can see here, the smaller we make the transistors, the more the current just leaks away.
And the fallout from this is huge. It's why your phone's battery drains even when you're not using it. It makes our gadgets less reliable. And most importantly, it's thrown a giant wrench into Moore's law. It's a fundamental physical barrier stopping us from making things even smaller.
So let's be super clear. This quantum leak isn't just some minor annoyance. It's a fundamental roadblock. It's one of the biggest reasons we can't just keep shrinking our tech into the future. It's a bug we literally can't patch.
But, and this is where the story gets really amazing. What if I told you that this technological bug is actually a universe-defining feature? Let's talk about how the stars use it to power up. That is not an exaggeration. The very same quantum rule that causes your phone to leak power is literally the reason the sun shines and stars burn across the entire universe.
See, for a star to shine, it needs to smash atoms together in a process called nuclear fusion. The problem is, the nuclei of atoms are positively charged, and they repel each other with an incredible force called the Coulomb barrier. It's like trying to push the north poles of two super strong magnets together. Classically speaking, the center of our sun just isn't hot enough for them to overcome that barrier.
But they don't need to break through it. They can cheat. They can tunnel. As this quote explains, quantum tunneling lets these nuclei slip right through that barrier, allowing fusion to happen at temperatures that would otherwise be way too low. So here's how it goes down inside a star. Two nuclei are racing towards each other. They hit that massive you shall not pass energy wall.
But instead of just bouncing off, quantum mechanics gives them a lottery ticket. And when that ticket hits, they tunnel through, they fuse together, and bam, a huge amount of energy is released.
And let's be clear, this isn't just a minor detail. Without quantum tunneling, the sun would just be a cold, dark ball of gas. The stars never would have turned on. There'd be no starlight, no heat, and probably no life as we know it. It's that fundamental.
So this all leads us to this really beautiful, kind of mind-bending conclusion. We've got one single, bizarre quantum rule that acts in completely opposite ways in two very different worlds.
On one hand, you have the tiny, microscopic world of our technology, and on the other, you have the vast, macro scale of the entire cosmos. One rule, two totally different outcomes. It's just incredible when you think about it. Down here in the world of computer chips, quantum tunneling is a glitch, a problem, a dead end we're trying to engineer our way around. But out there, in the hearts of stars, that exact same glitch is the creative spark that ignites galaxies.
And that's the thought I really want to leave you with. If this one strange rule can be both a bug and a feature, what other bizarre quantum principles are out there, hiding in plain sight, quietly shaping our reality in profound ways that we haven't even begun to understand? Thanks for joining me.